Hello geometry students. In this video we are going to talk about how to find the number of sides of a polygon, and we're going to talk about tessellations. Okay, so recall, to find the measure of an exterior angle of a regular polygon, we divide. If we do 360 divided by n, that's the number of sides, that'll tell us the measure of one exterior angle. Well, we can also use that kind of in reverse. We can divide the measure of an exterior angle to find the number of sides. If we do 360 divided by that exterior angle, we get n, where n is the number of sides. So whenever we're working with exterior, we're working with 360. If we divide by the number of sides, that tells us the measure of an angle, or if we do 360 divided by the angle, that tells us the number of sides. So all we need to do is find the exterior angle, and then 360 divided by that exterior angle. If we're already given the exterior angle, we just start with step 2, but if we're given an interior angle, then we start with finding the exterior angle, which would be this 180 minus the interior angle. For instance, the interior angle of a shape is 135 degrees. How many sides does this shape have? So I'm going to draw something over here, oh, that's not very good. Let me try that again. An interior and an exterior angle, they make a linear pair. So if we had some shape that looked, I don't know, I'm just going to draw a generic shape over here. It's going off my screen here. Okay, if my interior angle here is 135 degrees, then I can find this exterior angle here because the interior and the exterior form a linear pair. So 180 minus my interior angle gives me this exterior angle right here is 45 degrees. Now we just do 360 degrees divided by that exterior angle, and we get that this figure has 8 sides. Okay, so the first step, find the exterior angle and then divide. And that's all there is. For our next problem, how many sides does a regular polygon with an interior angle of 160 degrees have? First, we want to find the exterior angle. Okay, the exterior angle. If the interior is 160, imagine this is 160, then the exterior is going to be 20 because they are supplementary. So if our exterior angle is 20, then we do 360 divided by 20. And this figure would have 18 sides. If it's a regular polygon and the interior angle is 160 degrees, it's got 18 sides. For our next problem, each interior angle of a regular polygon measures 140. How many sides does it have? Let's find the exterior angle. The exterior angle, all right, if we've got an interior is 140, then our exterior has to be 40 because they form a linear pair. So our exterior is 40, and now we divide 360 divided by that. 360 divided by 40. This figure has 9 sides. Our next problem, how many sides does a regular polygon with an exterior angle of 18 degrees have? All right, we need to find the exterior angle. Well, here in this case, they gave us the exterior angle is 18, so all we have to do is that 360 divided by that 18. This figure will have 20 sides. All we have to do to find out how many sides a figure has, 360 divided by the exterior angle. All right, now we're going to talk about a geometric pattern called a tessellation. It's a design or a pattern in which a shape is used repeatedly to cover a plane with no gaps, overlaps, or empty spaces. Tile floors are a great example of this. Using squares, you can fill up a space by just using squares over and over. Here's an example of some hexagons. Here's another example of some hexagons. These figures down here, these are not regular polygons. This one over here on the left, this is not even a polygon because it's got curved sides, but this shape is being repeated over and over. That's a tessellation. This one right here is very interesting because it's got arrows pointing in both directions, but the space is being filled completely with just that same shape over and over, so it's a tessellation. Other examples, this is called a semi-regular tessellation up here because it uses more than one shape. A lot of times your bathroom tiles or kitchen tiles will have something like this pattern where there's more than one shape, semi-regular. These all are more creative examples of tessellations. I love this one with the turtles up here. And when you start adding in color, you can get some really vibrant, interesting designs. This one over here is just triangles repeated over and over, but with some different shading patterns. We got this leaf. Some of these are turned differently. These puzzle pieces, these kind of flower-looking things that are really made of pentagons. Tessellations. It's just a shape repeated over and over. There was a really cool artist named M.C. Escher who did a lot of stuff with tessellations. These are obviously not regular polygons, but if you're interested in art, I encourage you to explore the work of M.C. Escher. This one over here with these red and white, I don't even know if they're fish or birds, creatures. Over here we've got the blue birds going in one direction, the white going another. He did several pictures with his lizards right here. This one's one of my favorites. Also these things that look like a Pegasus. I've got these butterflies here and these fish. He did a lot of really creative work with tessellations. What do you need to know about tessellations? Don't worry, you don't need to be able to do all of that with tessellations. What you need to know about tessellations is which regular polygons will tessellate. Triangles will tessellate, quadrilaterals will tessellate, and regular hexagons will tessellate because their interior angles are a factor of 360. Those are the only regular polygons that will tessellate, that will fill a plane by themselves without any other shapes being used. Here's your example, your triangles, here's some squares, rectangles will also work, and here's your hexagon. Other shapes don't tessellate very well. This pentagon and this octagon, you can see that these would not fit together because their interior angles are not a factor of 360. Now sometimes you see a soccer ball which has hexagons and pentagons combinations. That would be a semi-regular pattern. But the only ones that will work with just one shape repeated over and over with no gaps, overlaps, or spaces, the only ones that work are triangles, quadrilaterals, and regular hexagons. That's what you need to know about tessellations. Now you should complete the Unit 7 Polygons practice quiz in Canvas. This will be a grade for completion, not for accuracy. We will go over the answers next class, and next class our test will also be assigned. That's all. Bye.